Okay, let's go to inverse functions part 12. This is the 12th video, all of them today. Um, I was saying before the last video ended up suddenly, uh, I was trying to say that since the derivative at a point at 3 is 0, since the derivative at 3, as you can see, is 0, this means, and when x equals 3, y is 6, right? This means 3, 6. At this point, what do we have? We have horizontal tangent. Horizontal tangent at this point. It just helped me to draw, that's all. It's just help to draw, okay? And it's easy now to finish our work. Before I draw, this is the last thing. We're almost done. Okay, let me draw first the axis. This is the y-axis, and this is the x-axis, right? And as well, we have to draw the y equal x, right? Y equal x, a straight line, y equal x. We said it's a must to draw the inverse function because they are symmetrical with respect to this line. Okay, this is y equal x, this is the y-axis, and this is the x-axis. Now, we didn't find any point of intersection, if you remember. We did y equal y, we didn't find any point of intersection, so we don't care to put anything here. But at point 3, 6, we have horizontal tangent. So 1, let's make it smaller. 1, 2, 3, 1, 2, 3, 4, 5, let's say 6. Let's say here. Here there is a point called of abscissa 3, ordinate 6. We have a horizontal tangent on it because the derivative at this point 3, it's 0. When the derivative is 0, this means the slope is horizontal. When the slope is 0, this means the straight line at this point is horizontal, right? The tangent at this point is horizontal tangent. This is very important, and it helps us to draw. It really helps us, and you'll see. What else we have to do? Let me also erase this. I will tell you. No, we don't need to do that. We don't need to do that. Let me put it back. Okay. What we need to do, what is important to do, is to draw the horizontal, the oblique asymptote. We got an oblique asymptote, if you remember, at the beginning of video, previous video, video 11. It was y equal x plus 1. Okay, let's draw this straight line. Xy, when x is 0, y is 1. When y is 0, x is minus 1. 0, 1, 0 abscissa 1 ordinate. 1, minus 1 abscissa 0 ordinate. Okay, this is a horizontal. This is an oblique asymptote from this point to this point, right? This is oblique asymptote. Asymptote is very important. Okay, let me make it red. Another red oblique asymptote I will do. Another oblique asymptote we will do with why we have another oblique asymptote. If you remember in the remarks when we started in the property, when we started this chapter, we said if we have oblique asymptote, we have oblique also for the inverse function. How? We take y equal x plus 1 and we interchange x equal y plus 1 and we find y equal x minus 1. This is another oblique asymptote for the inverse function. xy, if x is 0, y is minus 1. If y is 0, x is 1. So 0 minus 1, one of the points, 0 minus 1, and 1, 0, another point. 0 minus 1, somewhere here, 1, 0. Also, I will do it in red. Okay. You see, they are all parallel. My drawing is not that correct. But the two asymptotes, the two red ones, asymptotes, and the y equal x, they have the same slope. 1. Y equal x slope is 1. And y equal x minus plus 1. Y equal x minus 1. All of them have the same slope, so they are parallel lines. Also this point, this important point here, 3, 6, we have another point inverse to it, so it's a 6, 3, right? To draw 6 abscissa, 4, 5, 6, and the 3 ordinate. 1, 2, 3 ordinate. It's somewhere here. Since at the original point here, 3, 6, we have horizontal tangent, then here we will have a vertical tangent because it's inverse. And that's it. It goes all the way increasing, if you remember. So we draw, it's a tangent here, line tangent here. We don't need the other part, just from the point exactly and up. This will be the curve of the function. It's inverse because this is a horizontal line, right? Oblique asymptote, I mean. It goes to oblique asymptote. I told you I have to remove this, right? Okay. This is the oblique asymptote. This one is y equal x in the middle, right? So it goes all the way to the oblique asymptote from the point and the point to the infinity, right? And here from this and the point, tangent to it as vertical, and it goes all the way. To draw exactly, it's much better to do this. That's it. And I guess we are done, except if we need to find something. I didn't read it yet. No, just plot. I don't know if we can add something to this video. Maybe we find the inverse. So we don't need to do, but if you want, you can do it by yourself. Find the expression of inverse function. Find the expression of inverse function. We can do it if you want. Let's do it yourself. All right. So see you later.